I have to jump in here before I lose my voice. Allergy season has finally gotten here, so, oh God. Let's do this. So today we're going to solve quadratics by square roots. And I'm going to give you all a couple of examples to watch on your computers. That way you can look for these similar problems throughout the Canvas assignment I've sent you, okay? So here's an example. How can we solve a quadratic by square roots? You're going to see that we're still setting these equal to 0, or some of them have not been set equal to 0. For example, if this is set equal to 0, is there an alternative? And this is another alternative. I see something almost immediately that tells me I can add 36 to both sides, giving me a positive radical, not a negative one. And these are just strategies that you need to familiarize yourself with, get comfortable with. Now, if I take the square root of both sides, that index cancels that exponent, and x's will equal. And what I do to one side, I do to the other. It will equal a positive and a negative 6. So you have solutions of x equals, and it goes from -6 to 6. It's just a habit. So I will accept any answers as long as you're following the instructions in Canvas. It should be very self-explanatory. This is just a way to show your work and support your own answers throughout your EOC. Okay, here's another one. What if your next example, and I don't want to run off the page, so hopefully during all of this, I remember to slide the paper up. So let's keep going. If you need to pause at any time to write this problem down, or would prefer to have examples at your disposal, feel free, okay? So say, for example, now you have x squared plus 8 equals 57. We have to really think about this one. What is the difference between these numbers? Before I jump into the quadratic formula, or I want to look for relationships between numbers. And in my mind, I immediately see the possibility and the potential of, what if I did take 8 away from 57? I have a very quick response to that, and I know I've got +7, -7. So exploring the difference between these two here allowed me a quick 7 and -7. And again, you might see it as a multiple choice, and they could put this here in a set. So it could go either way for you. Today's activity, though, is very digital. It's going to either be type it in yourself or fill in the blanks or drag and drop. I did create drag and drops and fill in the blanks. I did not make any multiple choices because we need to know this with or without A, B, C, and D. All right, let's try another one. What if you have another problem? Say, for example, you get something crazy like, 9x squared equals 81. Well, I see a relationship between 81 and 9 if we know our division and our times tables. I can isolate x squared further, which basically the square root method is always isolate x squared and see if there is the potential there to take an easy square root. Alrighty, so 81 divided by 9 is 9, and x squared equals 9, and the square root of 9 is plus or minus 3. And again, or it could be a set. So you're just, you never know what you'll encounter. So we just want to be prepared for every event. And I hope my voice is coming across okay. Oh, dear God. All right. And here we go. On we move. Again, feel free to write down examples. Example, let's see, how many have I got here? Oh, there is a possibility that you could get these numbers set up this way. Now, I do see a relationship here, but be prepared. This isn't something that can't be done. This is something that's fun, you know. All right, so I know I've got x squared is equal to 9 over 4. Well, if x squared equals 9 over 4, what I do to one side, I do to everything on the other side. I just keep it as a fraction when I'm done. So that means x's will be equal to the square root of 9. Oh, and they're positive or negative, and it's a 3/2. So you might get fractional solutions. So be prepared for every event, okay? Just trying to get ready, okay? All right, so that would be example number 4. I've only got 3 to go, and then I'm gonna hit stop. Now, the next ones, they are going to be not so sweet. So if you are having any difficult, oh, that's my antihistamine, I'm so sorry, y'all. Oopsies. I'm on meds. Yes, we don't hug each other anymore until all the allergy seasons are gone. Yeah. You know who I'm talking to, by the way. Because if a fever comes around. Oof. All right. Okay, x squared minus 10 equals 0. All right. So you are also going to get some of those not so perfect answers, okay? When that happens, you can still take the square root, because if you were to use the quadratic formula on this, you're going to get the same result. All right, so here we go. It's a really fast way to say, you know what, I can do the same thing. I can say that adding 10 to both sides gives me the positive number necessary to take a square root, because we don't want any non-real answers in Algebra 1, so what we want are 10, and we take the square root of both sides, and x is equal to the positive or negative square root of 10, and that's how we keep it. And that would be your written response. Or in this case, if you were to type it in, you would have to type x equals square root of 10. Oh, negative square root of 10. X equals square root of 10. All right, so if you have fill in the blank and it has 2 blanks, you'd want to fill that in. Oh gosh. Okay. So let's try, okay, here's another one. I'll save the doozy for last, but here's a good one. Just use all of these examples, you guys, on the digital canvas and work it out. Practice, practice, practice. Practice makes perfect. Okay? I've been laid up in bed since Saturday night, and I said, okay, I'm just going to build. And I built plenty of problems for everybody. And I just want you to make every effort to do your absolute best. Okay? So here's our next problem. Now, again, this is balancing 101. So if I know how to isolate x squared, this is inverse isolation 101. This takes you back to balancing equations. The only difference is x is squared. It's just not an x, it's x squared. So what would I do first? 72 doesn't belong here. So we subtract 72 from both sides. We still have negative 2x squared that equals, in this case, that would be a 64. Negative 64. And now I can see closer and closer that we have I'm running low on battery, so y'all bear with me. It was recording and then it froze my screen. So I'm gonna hurry up. I've got one more problem. When you know my battery sucks. Okay, thank you. All right, so negative 64 divided by 2, that's x squared, equals positive 32. All right, so this means on the other side, I need to take the square root of 32, but 32 is a composite number. So over here on the side, I have a t-tree, or t-chart, tree, whatever you want to call it. All right, so if I have the square root of 32, that's the same as saying the square root of 2 times the square root of 16. But one of these is perfect. Well, if the square root of 16 is the perfect one, then we take the square root of 16 out as a 4, and we have 4 times the square root of 2. So we will have, in our x's, it equals positive or negative 4 square root 2. If you are having difficulty, there's a previous assignment in Canvas, and it's entitled, Do You Recall Your Radicals? And you can practice that exercise as well for a grade. Again, I've been laid up in bed since Saturday. I built and built and built. Okay, so here we go. So x's could be also x equals, and it could be a set of negative 4 square root 2 or 4 square root 2. Okay? All right. Last example. Hopefully I have enough time in my phone to do that. All right. Last but not least, what if you have 2/5, x squared plus 11 equals 61. And now this is a relationship a little bit harder to see, but since today's exercise is all about square roots anyway, this is the method you can apply on this one. I guarantee you it will still work. Okay, so you subtract 11 from both sides. In your problem, you would have a fraction times x squared plus a number minus a number equals to some other number. But once you are doing your inverse isolation of everything, you would have a 50. And what is 2/5 x squared equal to 50? Well, I want to change this to a 1. And this isn't technically the structure I'd use. Most of the time I put parentheses here and I multiply by the reciprocal, but I am literally going to do it So what am I doing? I'm going to go 5 times and 2 times, because that gives me over here, and this is in my own mind, and this should be something you should be understanding about the reciprocal. When we multiply by the reciprocal, these two numbers become 10 over 10. 10 over 10 is 1. So now I've officially got a 1 that I no longer have to write. This is why we multiply by the reciprocal. So these cross cancel into a 1, and I have x squared. But since I multiplied by 5 on this side, I multiply by 5 on this side and divide by 2. Okay? So that is 250 divided by 2 is 125. Okay? So this now needs a square root of 125. So I come over here and I say, okay, well, what is the square root of 125? Square root of 125 is the square root of 5 times the square root of 25. Well, I know the square root of 25 comes out as positive or negative 5. That's my new answer. So I brought it out. And there we go. So all my x's are equal to a positive or negative 5 times the square root of 5. Or fill in the blank could be so be ready, okay? It could have, oops, a little loopy there. Could have all of that. All right, so use this video and use every example. If you've got to hit reverse, or reverse, oh, I hate getting colds. If you have to hit rewind and find the problem that most resembles the problem you're faced with. I try to look through every one of my examples, and I've given you 7 different kinds of problems that would jump out at you as resembling everything that you'll work on today, okay? So do your very best, and extra attempts will be made for you to take it again and again until you're completely masterful. So best wishes, and I hope I get well real soon. Okay, love you guys.